Welcome to Arnold's and another no bullshit session. Today's session is going to be on slope. Why is slope important? We need to have a basic understanding of slope so that we can communicate with each other and do it precisely. Rather than just saying, oh, it's kind of this steep out there, we need to be able to have something more specific. We need to be able to, when we're out in the field, we need to be able to visualize slope and figure out what that is, and so that we can communicate with each other and talk about it. We need to recognize that there's different erosion control methods for different slopes. A flat slope, in slight slopes, we might use just blowing straw and then crimping that straw in. For steeper slopes, probably need to use something more aggressive, like some kind of a hydromulch. And last of all, we need to talk about slope for safety. What can we put our tractors on that is too steep that we would slide and be in a dangerous situation, or even roll some piece of equipment? So today we're going to talk about slope. So what is slope and how do we calculate it? If we have some slope represented by a line, we want to take and define slope as the rise. So we figure out in a given length, this length here, how much rise we're going to have. So we call this part the run, and we call this part the rise. That ratio of rise over run will give us our slope. So slope then is equal to rise divided by run. So let's do a quick example. I've tried to draw this with a run that's approximately 100 units, we'll call it feet, long. And the rise is about 25 units, which we'll call 25 feet high. Typically you'll use a 100-foot run when you're calculating slope. Makes the math easy. So our rise, 25 feet, put that here in the numerator. In the denominator we put in 100, and of course that ratio comes out to be 0.25. 0.25 is the slope of that line. Typically we talk about that in terms of a percentage, so with percentage, of course, you just move that decimal point 2 places over and we get 25%. So the slope of that particular line is approximately 25%. So 25% or percentage of slope is one way to talk about this slope, but there's also various other ways to talk about the slope. Common to our industry, for example, instead of talking about a 100-foot run, guys will talk about this in units of 4. So this is 4 units of run and 1 unit of rise, and they'll talk about that in a 4-to-1 slope. That is the same thing as 25%, which is the same thing as 0.25 slope. So the other way that you might talk about this, if you've been in the roofing industry, is they talk about slope in terms of pitch. They'll talk about the pitch of a roof. So if you were to think of this run as 12 feet, and the rise would be 4 feet, or 12 inches and 4 inches, you would have a 4 in 12 pitch. That is the same thing as 25%. Another way to talk about the slope of this line is to talk about it in terms of degrees above the horizon. And that would be this angle here. If you were to take this line and see how much degrees that was through there, that would be 14 approximately degrees. So there's various ways of talking about this line in this slope on this line. If we were to think about it in terms of a different line, let's think about it in terms of a slope of 3-to-1. So there's 1, 2, 3 units that way, and 1 unit up. If I were to draw a line between those 2 points, that is what we would in our industry call a 3-to-1 slope. Happens to be 3 units of eraser, but it could be 30 feet and 10 feet, or 3 yards and 1 yard, doesn't matter. That is a 3-to-1 slope. 3-to-1 slope happens to be 33%, and it also happens to be the angle at which we put a maximum slope that we will put a tractor on. So if we're sitting here in our tractor, we got our treads going here, 33% is about the same slope, the maximum slope that we'll put a tractor on. Again, there's different ways of talking about this, and understanding all of that language is important. The one that gets the most confusing is when we talk about it in 3-to-1, or in 4-to-1, or 5-to-1. The reason it's confusing is because they're talking about the length. Typically slope is rise over run, but in this situation they're talking about the run first and then the rise. So in this case, a 3-to-1 slope is less steep than a 2-to-1 slope. So even though the first number that we're talking about is greater, that means that there's less slope. So if I were to draw a 2-to-1 real quick, which is too steep to put a tractor on, that's 2 units, 1, 2, horizontal, and 1 unit vertical. That's a 2-to-1 slope. So we have a little demonstration here for slope, and as you can see, I can tilt this up, and our little wooden tractor here will give some slope. Hey, can I get a volunteer to show us what this slope is? Anyone? Anyone?
I'll do it.
Matt, come on in. Matt Bumgardner here, BA. He has on his phone a handy dandy little tilt meter, slope meter, what's it called?
Tilt meter.
Okay. So put that on there, Matt, and tell us what slope we have here.
Right there is about 17%.
17%.
There's a 26.
25% right there, which is a 4-in-1 slope. And tell us when we get to about 33%.
Right there's 33%.
That's about the max slope that we'll put our tractors on. You know, sometimes you'll get into a little bit steeper and it'll start to slide. What do you do, Matt, when you're on a slope and the tractor starts to slide?
So a safety method that we need to use is you're going across the slope here and you realize that your tractor starts to slide down, is to face your tractor downhill and continue going forward, but to get it pointed downhill to where you can slow down, you can get it under control.
Thanks for that, Matt. Appreciate it.
Very welcome.
Wow, a lot of information to take in, right? Well, to make things easier, we've created a Arnolds Slope cheat sheet. Get yourself one of these. Basically, it talks about all of the things that we talked about here in a table format, so you can convert what, if you think about things in percentage, you can convert that percentage back down to common language, 4-to-1 slope, or we have on here 4 and 12, and all the different ways that you can talk about slope. Makes it real easy. Another thing that you can do is look at our grid system. We created a little grid here, 100 units wide and 100 units tall, and that will help you visualize some of these lines. Another really handy tool for those of you that have smartphones, there is an application called Tilt Meter. And Tilt Meter, what you can do is hold that up to a line. That line that I drew, this says 25%. By gosh, that's 25%. This says 33%. This is a 33% line. This is a 2-to-1 line. 2-to-1 should be about 50%, and that is roughly 50%. You can use this in the tractor. You can use this on slopes. You can, eye it and get your slope by eyeballing it. If you're at the toe of a slope and you're eyeballing at the top of the slope, you can't eyeball the top of the slope. You have to account for a little bit of extra height. So if you have somebody that's standing on the top of that slope and you're eyeballing them at their eyeball level and they're about your same height, you'll get the proper slope on that. So next we want to talk about slope distance. Slope distance is this distance from this point to this point. So Let me erase this. This is slope distance. From here to here. This one down here is the horizontal distance. The horizontal distance is always going to be less than the slope distance. And this is important because when we get on steep slopes and we're laying blanket on steep slopes, if we're charging the client for the horizontal distance, that horizontal distance will be less than the slope distance of the actual blanket that we're laying, and we won't be charging enough for that. So if you're going to all the effort, let's say you're on a really steep, almost a one-to-one slope here that I've drawn, and you're up here, you got your crew out here, and you're rolling this blanket down the hill, that distance can be significantly more than the horizontal distance. So you just can't use the stations off of the alignment sheets. And we'll talk about that more in another video. We will lose over 40% of our revenue on this task if we don't understand the difference between horizontal distance and slope distance. Here's why. As I talked about earlier, if this is one unit, let's say it's 100 feet on our horizontal distance, and our vertical distance is 100 feet also, the length of this line will be 141 feet. That's the slope distance that we need to measure. The most accurate way to measure slope distance is with a wheel or with a tape or some physical way of measuring that distance. If, for example, you use a GPS coordinate system and you were to take a GPS measurement here, or walk the perimeter, so to speak, in here, you're actually going to get the calculation on the GPS system of that line, or that extension of that line, of that area. You're not going to get this area, and we're going to have 40% less billing in this situation than we should have. So, if you don't know the slope, you can calculate the slope using your slope meter, and on our handy dandy little Arnold's slope cheat sheet, you can say, okay, I have a 1-to-1 slope. What is my area difference? That column on that sheet, the area difference, will give you a factor to multiply it by. In the case of a 1-to-1 slope, you have to multiply it by 1.41. So if you were to have this area, the flat area that you did with your GPS unit, and you know it's a 1-to-1 slope, you can multiply that by 1.41 and you'll come up with the right amount of area. Here's how that looks. So we have our 100 foot, could be a linear measurement or could be an area. Multiply that times the handy dandy conversion factor of 1.41. That will then equal 141. That is the same as that by using this sheet. When you have a situation where you have to figure out slope distance using your prints or your drawings, how do you do that? Well, let's take a look real quick. Let's say that you were able to determine that you have a horizontal distance, and you can do this from the station numbers off the prints. Let's say you determine that it's 45 foot long. And you also determined from the elevation numbers on the prints that it's 35 feet high. How then do you determine what the slope distance is so that you can estimate the area that we have to buy materials for, to lay blanket or to buy hydromulch for, or whatever the case may be? In this situation, to calculate that distance, we use what's called the Pythagorean theorem. And that is a squared plus b squared equals c squared. So if we have a triangle, this is a right triangle. This is side A, this is side B, and this is side C. Let's simplify that. What we physically do is we're going to take our calculator out, and we're going to multiply 45 times 45. With that, we're going to get 2,025. And on this one over here, we're going to take 35 times 35. That's the square. 35 times 35 is 1,225. So what I said was a squared plus b squared is equal to c squared. So we have to add these two numbers, this 35 and this 45 square. So we take that, 1,225 plus 2,025, and that equals 3,250. So then, to get c, which is the length that we're going for, we simply have to take the square root. So find that symbol on your calculator, put in 3,250, hit the square root number, and you're going to come up with the result of 57. So that slope distance is 57. So in summary, slope, when you break it down, it's not all that complicated. You have your horizontal distance, your vertical distance, which we call rise. Your horizontal distance is called run. Rise over run is slope. When you're talking about that division or that ratio, there's different ways to talk about it, whether it's percentage or degrees or 15 and 100. Understanding those basic things and having that common language is really important for our industry. Understand that different people talk about it different ways, so be precise in your language. Be able to use the tools that we've given you to help visualize the slope. Tools could be as close as handy as in your pocket with your smartphones. Recognize that there's different slopes. We do different things for erosion control in our industry. Flat slopes will do something different than we'll do on steep slopes. And understanding that's very important. Finally, safety. When you get into something that's you have a tractor on and you're on more than a 3-to-1 slope and the tractor starts to slide, what do? You turn into the direction of this slide, down the hill, drive right out of that. So be safe out there, understand these basic components, think about it in simple terms, and you'll do great.